All right, now we are going to do another example. We're looking under the same general example. So the specific brand of batteries that are normally distributed have a mean lifespan of 500 days with a standard deviation of 61 days. So let's write down mu equals 500, sigma equals 61. Now we're going to find the probability that an individual battery lasts more than 300 days. So for this one, we need to find the probability. We're looking at an individual battery, but now we're looking at more than 300 days. So just like in the last one, the first thing we're going to do is calculate our z-score. So our z-score formula is x minus mu over sigma. So our x value this time is 300. Our mu is 500. And our sigma is 61. So 300 minus 500 is negative 200 divided by 61. That gives us negative 3.279 when I round that to 3 decimals. So the middle of my curve is 0, negative 1, negative 2, negative 3, negative 4. This is step 2. Draw your curve and label your z-score. And then our z-score, negative 3.279. That's pretty far out there. Between 3 and 4, a little bit closer to 3, not quite halfway. And then step 3 is to shade the area that we want to find. Our keyword this time is more than. So that means we're going to shade everything to the right of our z-score. So that's all of this. So now looking at this, it looks like I've shaded pretty much the entire curve. But remember, the normal distribution is an asymptote. So even though it doesn't look like there's any area left in between, there is. But this answer is going to be really close to 1 because there's very little space left. So now I'm going to look at Excel. And this time I'm going to go straight into Excel. Okay, so that is the answer from the previous example that we worked. So I'm going to come down a line. So to find area with a normal distribution, we do norm.s.dist. We put in our z-score, negative 3.279. And then if we put in false, it's going to give us just the individual z-score itself. If we put in true, it's going to give us the cumulative probability. So it's going to give us everything to the left. 0.000521. Well, that doesn't look right. Oh wait, I'm in Excel. I clicked on the wrong thing. 0.00521. Okay, let's see. I did norm dot s dot dist negative 3.279 comma true. That's what I did last time. And I got 0.000521. But that doesn't look like the answer I should have gotten. My answer should be close to 1, not 0. Think about that for a second. Pause the video if you need to. Take a moment. See if you can figure out why my answer might be looking a little weird. I'll give you the answer in a second. So the reason the answer looks weird is because Excel will only give you the area to the left. So this is the probability of being less than. But that's not what we wanted. We wanted the probability of more than. So we have this probability. We want the other probability. So in order to get that, we have to do 1 minus this probability. And you can do that by either taking the probability after you calculate it in Excel, or you can do it from the beginning. But we have to use the complement rule. Excel gave us what we don't want, so we use the complement rule to get what we do want. And I want to put my equal sign down here. So let me go up into Excel again so that I can show how this works. So we do equals 1 minus norm.s.dist negative 3.279 comma true. So it's very similar. All I did was add 1 minus to the front. And when I do that, it's going to calculate the probability, and then it's going to take the complement. And by taking the complement, I get the area to the right. 0.999479, which is 1 minus this number that I originally calculated. So 0.999479. And we can round that to 4 decimals, so that would be 0.9995. So the probability that a battery lasts more than 300 days is 0.9995. It would be very unlikely that a battery does not last more than 300 days. Your batteries are probably going to last more than 300 days. So that is how you can calculate the probability of more than with something that is normally distributed.